Hi everyone, we are group 9 and today we're going to present about the double integral over non-rectangular regions and applications of double integrals area. I'm Login and I'm from group 9 and I'm the GM in this group. So let's talk about the first topic, double integral over non-rectangular regions. So in this topic, we separate it into two types, which is type 1 and type 2. Oops. So let's talk about the type 1 first. As you can see, we have the upper boundary here, which let's call it y equals to g2 of x, and we have a lower boundary here. Let's call it y equals to g1 of x. So for the vertically, we say that there are lines that found the regions. So obviously it's A and B. So type 1 region would be the underneath and above. There's some functions of curve, but from the left to right, we have an actual line as the boundary. So if you are going to set up a double integral over a regions where you are using a curve in the y direction, that means these two functions, and obviously here is how it's set up. So for the direction that has curve as the boundary, that is the direction you are going to integrate first. So we're gonna put the g1 of x, whatever the g1 of x is, it would be our lower boundary, and obviously the y equals to g2 of x would be our upper boundary. So now we are going to A and B now. That's very important that any function that you have are always on the inside of integral. So, and your constants are always going to be the outside. Which means A and B are going to be the outside. Okay, so now let's talk about the type 2. As you can see, the type 2 is almost the same with type 1, but there is a big difference, which is the direction of the type 2 is exactly opposite with type 1. So for type 2, our curves may be on left and right. So let's say the left curve is x equals to h1 of y, and this is x equals to h2 of y. Then let's go for the horizontal lines, which is C and D. Alright. So if you are going to set up, the equations, and here is how it's set up. Alright. So on the left, the leftmost curve, which is x equals to h1 of y, would be our lower boundary, the h1 of y here. So obviously the rightmost curve, x equals to h2 of y, would be our upper boundary here. So in the y direction, obviously is C to D. So obviously the constant would be the outside. As I say just now, the function would be the inside of the integral and the constant would be the outside. Alright, so now let's take a look with the example.
Hi, I am Amar. I am R&D staff for Group 9. Today I will talk about example for double integral over non-rectangular region. Okay, double integral over non-rectangular region. For this example, I will from this graph, I will draw one line parallel with y to find the upper and the lower limit for y. Okay, so the upper limit for y is 2x and the lower limit for y is x squared. Okay, so the given function here is z equal to 3x plus 1. Okay, we will use in the next slide. Okay, to solve the solution, sorry, the upper limit and the lower limit, just like the previous slide, we fill into the new function to solve this question. So we will integrate two times. The first one we will integrate with 2x and x squared with dy, and then we will integrate the second part with 2 and 0 with dx. Okay, first we will integrate 3x plus 1 with dy, and then we will get 3xy plus y dx, and then we multiply with 3x, 2x, and x squared. And then we will get like this. After that, we will integrate with 2x dx, and then we will get like this. Okay, this is 2, 0, and then we change the x in 2 and 0. If we change to 0, the answer will 0, and then we just take 2 to the x, into the x, and then we will get 16 over 3 is the answer. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Deka bin Muhammad Nizam, and I am an IT manager for this game. So I will proceed with the next part, which is double integral of a non-rectangular region. So here is the question. Find the volume for double integral xy squared dA, where d is a bounded region by y equal to x and y equal to x squared. So for the first step, we have to kita kena lakar graph tersebut. So this is the graph that we get from the equation given. And for the next step, we have to find the lower and upper limit for both x and y integration. So to find x integration, we have to draw a horizontal line cutting through this region, and we can get the upper limit for x is 1 and the lower limit of x is equal to 0. And to find y integration, to find y limit, so we have to repeat the same method, but this time we have to cut through this region vertically, and then we can get y equal, the upper limit of y is y equal to x, and the lower limit of y is y equal to x squared. So for the next step, we have to integrate y toward, we have to integrate y divided by y. So we can get 1 over, so we will get integrate 1 over 3 xy to the power of 3, lower upper limit x and lower limit x squared dx, and bila kita kembangkan dia, kita akan dapat integrate 1 over 3 x to the power of 4 minus 1 over 3 x to the power of 7 dx. And then lastly, we have to integrate dx towards x. So we will get 1 over 50 x to the power of 5 minus 1 over 24 x to the power of 8 and 0. And then we get 1 over 15 minus 1 over 24, and the final answer we will get is 1 over 40 unit cube. So that's all from me. Thank you.
Assalamualaikum. I am Muhammad Ajrun bin Zaibun, and I'm the secretary for this GM in this group, and I'm going to talk about the application of double integral focus on area. And the double integral can use it for find the area of a region bounded by cofunction. So if the region is a rectangular shape, we can find its area by integral the constant function fxy equal 1 over the region R. Okay, for the formula, area is double integral R1 dA. Okay, this definition actually makes sense because for using fx y equal 1 and evaluate the integral, make it a product of length and y. And it can be written as ds dy or dy dx.
Assalamualaikum and hi, my name is Luqman Hakim bin Anwar and I'm the engineer of Group 9. And my subtopic is application of double integral and I'm taking the part of area. Okay, so this is my example. Okay, use a double integral to calculate the area enclosed between y equal to 1 over 2x squared and y equal to 3x minus x squared. Okay, the graph that we got from the equation, the question is the upper line is y equal to 3x minus x squared and the below line is y equal to 1 over 2x squared. Okay, if we want to get the double integral equation, we need to extract this and it becomes like this. Okay, if say the square is 1 at 1 unit at each side, then we can differentiate it to its perspective. Then it will become like this. Okay, the inner integration first, y equal to from y equal to 1 over 2x squared to y equal to 3x minus x squared 1 dy, and the outer integration is from x equal to 0 to x equal to 2 dx. Then we can solve the inner integration. Okay, from x equal to 0 to x equal to 2, open bracket, y from y equal to 1 over 2x squared y to y equal to 3x minus x squared. Then we can insert the equation. Then it will become like this. From x equal to 0 to x equal to 2, open bracket, 3x minus x squared, 3x minus x squared, minus 1 over 2x squared, and close bracket dx. Then we can solve the outer integration to get the answer. From x equal to 0 to x equal to 2, close bracket, we simplify from the before equation. Then it becomes like this, 3x squared over 2 minus 3 over 2 multiply x cubic over 3 from 0 to 2. Then we can simplify by cut 3. Then we can solve it by inserting the value inside. 3 open bracket 2 cube over 2 minus open bracket 2 cubic over 2 close bracket minus 0. Then we get the answer is 2 unit.